For centuries, we believed this was the only way. We searched for life by searching for worlds like our own.
But this is a lie. This is Europa, a moon of Jupiter. But the most exciting frontier in the search for life is not on the surface. It's beneath it. And beneath that shell lies the single most promising target in our solar system.
An ocean that holds more water than all the oceans of Earth combined.
How do we know it's there? This isn't just a guess. In the 1990s, the Galileo spacecraft.
What it found was astonishing. The moon had a disrupted magnetic signature, one that could only be explained.
Then there's the surface itself. It's not a solid, ancient block. It's cracked. Regions where the icy crust has clearly broken apart, shifted and refrozen, as if it were floating on something vast and liquid below.
But the true smoking gun wasn't found at Jupiter. It was found at Saturn.
This is Enceladus, one of Saturn's moons. In 2005,
Cassini did something incredible. It flew right through them. And it tasted the ocean. That silica is the key. Those tiny sand particles can only form when hot, mineral-rich
was definitive proof. Miles beneath the ice of Enceladus, there is a hot, rocky seafloor.
How could life survive in this total darkness, miles beneath an icy shell? On Earth, the sun is the base of the food chain. In a dark ocean, what would life eat?
The answer was found on our own planet. In 1977, scientists exploring the deep entire ecosystems, divorced from the sun. The creatures here don't eat sunlight. They eat chemicals.
This is chemosynthesis. At the base of this food web are not plants, but bacteria and archaea. These mats of bacteria become the grass of the deep. Vent shrimp, yeti crabs, and tube worms feast on them.
But what provides the heat? What powers these vents? The answer is gravity.
These moons are in a constant, brutal tug of war. The immense gravity of their parent planet.
This process is called tidal friction. It generates enormous heat, melting the ice to form an ocean, and keeping the rocky core geologically active. It creates volcanoes and hydrothermal vents on the seafloor.
This means these dark oceans have all three ingredients necessary for life as we know it: liquid water,
So, what could be living there? This is no longer wild fantasy. This is plausible science.
Where there is prey, evolution will inevitably produce predators.
The dark oceans of our solar system are not science fiction. They are real. We are on the verge of finding out. NASA's Europa Clipper mission is on its way. Measuring the ice, and even sampling the plumes that may be erupting from its surface.
For all of human history, we have looked up at the stars and asked, are we alone? We've searched for life on distant, Earth-like planets. But the first definitive discovery of extra